Ahoy, mateys, and welcome to Expedition 345. Hess Deep Plutonic Crust brought to you by the Integrated Ocean Drilling Program. Set sail on December 11th, 2012, and returns to port February 10th, 2013. Aboard the Joy D's Resolution. This expedition will be drilling for the second time at the Hess Deep Ridge, located on the East Pacific Rise, and will study the crustal accretion process. During this process, materials such as sediment, volcanic arcs, and seamounts, and other igneous features are added to a landmass. But let's rewind a bit and figure out how crust is formed in the first place. The Earth is made of a few different parts: the core, the mantle, and the crust. The crust is formed by partially melted mantle rock, which is less dense than the surrounding rock. Gradually, this less dense mantle rock moves upward and enters the magma chamber, which is just below the ridge's crest. As the seafloor spreads apart, fractures develop in the crust that lies just above the magma chamber. Molten rock in the chamber is injected into these fractures. Eventually, the magma erupts through these fissures onto the ocean floor, but then is cooled quickly because of the temperature of the seawater, solidifying the magma into basalts, a type of rock. The basalts are found in the upper oceanic crust, and gabbros are formed at the places deeper down where the magma cools at a slower rate. The Hess Deep Rift was selected because of the, quote, young ocean crust that is made up of two components: basalts and gabbros. Scientists are particularly interested in the oceanic crust formed quickly because it is more uniform and homogeneous than the slow-spreading ridges. Fast-spreading rifts make up almost half of the oceanic crust, which is about 30% of the Earth. So it's important to study and understand as much as possible because this information helps us better understand other geochemical phases, such as the carbon cycle. This expedition will test the competing hypotheses of the magmatic accretion process. We will sample for the first time the primitive magmatic rocks of the lower crust, gabbros. We will gain insight on how molten rock is transported from the mantle through the crust. This expedition also hopes to test hydrothermal processes to figure out how fast heat is extracted from the lower plutonic crust. We also hope to gain a better understanding the significance of basalt and gabbro layering, as well as each of their components. All of this information will shed light on the evolution of the oceanic crust before it gets recycled back into the mantle, as well as understanding the fundamental role this plays in geochemical cycles across the globe. Make sure to check back for future animations explaining important concepts relating to this expedition.